Hi guys, it's Bob Greenyer here, volunteer with the Martin Fleischmann Memorial Project. Okay, so if someone can tell me if the sound is good, I don't want to mess this up, and I've got the mic in the right position today, so hopefully it's okay, so let me know. I'm going to just get something ready here, so if you can just let me know if the image is good. Okay, all good, excellent. Hi Charles, hi Artifact, hi Lafleur, hi Corky, hi Gordon, hi Ron. Excellent, fantastic. Okay, so I just want to get one other thing up. So I didn't intend to do a presentation today, but in my presentation yesterday, I talked about a particular type of mathematical solution to two solitons or pseudo-spherical surfaces. And I said I challenged people to go out and see if they can find the document. Well, Peter, I think he's in Japan, found the document and sent me a link, and I will show you a couple of images of that. And then that's from 2014, I think. It was reported by Jean-François Geneste in 2015 at the EADS conference, where he talked about the De Viau et al. Strange radiation tracks that they had recorded in 2010, I believe, when they were replicating the work of Leonid Roitzkiev. And he drew my attention to that. And we think, I believe that we've demonstrated that we are producing those kind of traces. And the tracks that he showed, or rather the pseudo-spherical or two soliton structures that were shown in his presentation, didn't quite fit what we were seeing in the reactor. And if you go and look at the book, you can see some lines that are very much closer to that. Anyway, Axel was ploughing on with that, and he found another document, which was in, I think, 2017, in the middle of 2017, actually, basically just after I saw my first strange radiation track in the echo fuel that had been exposing my Logitech web camera. And they say they corrected some of Popov's work, and I think it's Italian authors, but I need to verify that. But I think what we are going to be able to demonstrate today is the other types of strange radiation, which aren't simple toroid or sphere impacts, or large-scale crystal clusters of toroid, or the kind of mesh type structure effects from the work of Matsumoto, and similarly that we observed when we looked at the Dr. Royashin Umaza plates. This is, I think, it's not only that we have demonstrated in the work of Dave and Henk, these tracks could be produced by these things that we're seeing in the experiments. We have also seen it in the ultrasonic sphere. So what I'm going to do is going to a little bit of histrionics and go back to where my thinking was a few years ago and how we kind of arrived at this point. And then I want to kind of like, there's been an acceleration of findings over the last couple of years. And I think it's culminating to this point where we are seeing what I called a number of years ago the active agents in LENR, and it wasn't a specific singular thing. And I'm going to go back to some historical work that I referenced yesterday that was in the ultrasonic field, and that is the work of Roger Stringham, replicated most recently by Tom Claytor, and I saw that at ICCF 21 in Colorado. And also some other work which is relevant to look at this point. And I think you'll find some extremely interesting insights by Roger Stringham, and it's only really talking about production of helium from deuterium. But I think that the replication goes to show that this does not only produce fusion, it also produces fission and transmutation, and that is what we expect, or what I would expect, from the active agents in the LENR process. And I think what you are going to see when you take on board what I call the coherent matter that is forming in the exotic vacuum objects of the sphere type and the torus type, which can then form the clusters, the crystal clusters, and the mesh structures. The other kind of one that we're observing in this last, I think, part of, I don't want to say it, but I don't care if I'm wrong, I only care if I'm right, and I've said that for many years. I believe what we are seeing in strange radiation is the result of coherent matter, and specifically coherent matter traveling waves. And I think what we have already shown prior to what I'm going to show you today, a mathematical solution for traveling waves, is structures that are in the reactors of Henk and Dave, these kind of sapphire-inspired reactors that have taken the experimental to the max, experimental sort of iterations to the max, and the kind of waveforms that you're seeing in there, which don't seem to be very explicable. I think by the end of this presentation, I would hope that it just is what it is, and you will recognize that we are seeing coherent matter, and coherent matter that is traveling in a traveling wave way. Okay, so with that, I'm going to go and see if I can find a presentation that I wrote a while back. And so this is over 3 years ago, and it was called What Really Is New Fire Fuel. Okay, so let me see if I can punch this in. Okay, so hopefully you can see me there. I'll just see if there's any questions. So Evo t-shirt, yeah, it's actually coffee beans, but it looks a bit like a yin yang, I guess. And hi Kem, thank you for all your support to help me get there, get to this point. For me, this is the end of a particular torment that I've had ever since I saw my first strange radiation. I believe this is the end for me in this part of the journey, and I believe that hopefully many people will be able to accept that we are producing coherent matter, and that it can transmute matter, and that we do need to be aware that it can go into a neutral mode, and it can still be coherent matter but of a slightly different type, and then it can interact with other matter at a distance, has been reported by many people like Leclerc, and long before Leclerc you can look at Yul Brown, and long before him Ken Shoulders, and long before him John Hutchison. But really John Hutchison really is the key to a lot of this story, and maybe Yul Brown to a certain extent. His anecdote is very important in understanding this. Anyway, so I'm gonna what have I got here? So have I got what I want to show you right now? Okay, I'll leave that down there, I think. No, that's not gonna work. Oh dear. You can never have too many screens. Okay, right. Audio great. Okay. So this is a presentation I gave a good number of years ago called What is the Really Is New Fire Fuel. There's a video in there. You can go and have a look at that in your own time. But there's just a couple of points at the bottom here I just want to highlight. This is when I really started thinking about the Earth's crust being the guide to what we need to think about in terms of what is actually causing the LENR process. So let me see, is that gonna fit on the frame? Oh dear. Okay. And then I talked about the George-Oshawa cycle, and this is the cycle that goes on in ball lightning effectively, and you get carbon, nitrogen makes aluminium, 2 aluminium makes iron, aluminium and nitrogen makes calcium, aluminium and so on, and you get 2 carbon and oxygen makes silicon, silicon and oxygen makes titanium, and so forth. So when you add up all of these products that you essentially get from starting with carbon, protons, and lightning, effectively, you get almost all of the elements in your body. And so then I looked at all different types of experiments that we had conducted and had been conducted since this George Miley study at the University of Illinois in May 2009, where he was plotting all of the elements that have been repeatedly synthesized in LENR experiments, and I added on the few that either we were involved with or other parties had done since. And this told you a story about what happens. Now, you can imagine that you don't see things that are, it tended to push things into the small bottom there. But anyway, moving on, this was the fuel processor that Suhas Ralkar had, and this is a cavitator. And what you're seeing here are three cavitators here, which are 1.5 kilowatts each, and so this is 4.5 kilowatts of ultrasound into this chamber, and you can see the PZD transducers on the end here. And he ran this, he didn't really have active fuel until over 160 hours, and I argued that there was elemental transmutations in here, and I essentially argued that, and you'll see at the bottom of this Steemit blog, that what was going on was he was actually causing exotic vacuum objects and essentially the active agents to be stored in the metals that he was processing in here without actually realizing it. And what he was actually trying to do was to actually take off the shelf nickel or titanium or whatever, and he was trying to mill that down to his target, what he thought was a resonance size of, let's say, 5 microns, and then sieve that. But inadvertently in the process, I believe he was loading it to the gills with the active agents, the coherent matter exotic vacuum objects that were able to sit in that metal. And when it was excited with electrons in his corona discharge echo heat producing reactor, it was then feeding the beast, which could then consume material and produce excess energy. So and what I have agreed with Suhas Ralkar, that if we can get the university here involved in terms of testing this under the European program, and we have the funding in place to shift that to Europe, and it would help if there was some transfer of knowledge from Suhas Ralkar that we will be able to use this fuel generating device. And it's interesting because Russ George, who worked with Roger Stringham in his early work, actually visited me, I think it was at the end of this year, or I think it was January 2018 maybe, and I talked about this work. And when he went away, he started working on producing fuel using an ultrasonic mixer. But I think today, again, he was actually in that ultrasonic process. He was actually adding exotic vacuum objects into the metal, because if you remember, Ken Shoulder says these things can stay in metal indefinitely, and that was actually the active thing that was doing the job inside just a heating cell. So this helps people understand how you process fuel. But I argued that quite a lot in this document. So I went through a lot of la, and then I talked about Adamenko's work here and synthesizing. Then I'm talking about strange radiation tracks here, because we observed strange radiation tracks from the echo fuel, both on the actual fuel container, on the actual fuel with these spheres that get left behind, on plastic that was at a distance, both the 2-point holes, and remember you saw yesterday in the ultrasonic reactor, the ultrasonic device, one of these, this Vivreal device that Alan Cusk was using. I showed you the foil, and you can go to that remoteview.icu blog, and I put the images up there, but you can see these 2 holes in there. Well, you can actually see the 2 holes here on this polymer. You can see the 2 holes here, you can see the 2 holes here, there's 2 holes up here, and it's the same kind of thing, I believe, that you are seeing here. This is a more standard type of strange radiation track that you're seeing here, but it's the 2 holes that I found quite interesting. And I've done other studies on that, But the interesting thing is that this fuel was a couple of months old at this point, and this plastic was just the PET from a soda drinks bottle, and it was put over. It had an air gap between the plastic that you see here, so the emissions were coming from the fuel through the plastic, through the air, and into the plastic and interacting with the plastic. And so, you know, this wasn't an active fuel sorry, it was an active fuel, but it wasn't actually in a cavitator at the time. This is a long time afterwards. And then this was using the Logitech 910C. I produced these strange radiation tracks, so we'll go forward. And this is Nanospire, and these are the tracks that he observed, and he actually observed these in other parts of the lab. So there's a track here on copper, there's a track here on whatever the material is. There's a range of different tracks here, but they're the typical type of tracks that you see from this. And so you see Adamenko with his relativistic exploding one somewhere down here. He's got the tracks, and this was work with Vladimir Vysotsky. And I have to say, from the very first cold fusion conference I went to, ICCF 17 in Daejeon in South Korea, Vladimir Vysotsky's constant phrase of coherent correlated states, coherent correlated states, coherent correlated states. He like had 3 or 4 presentations, and he must have said it, I don't know, 100 times, 200 times. And what is coherent correlated states? Well, it's coherent and it's correlated, i.e. they're the same phase and the same frequency. You know, I kind of understand what he was trying to get across, but it you know, I listened to these things, but it wasn't so obvious at the time. And you know, it's one thing to have these witness materials, but it's a very different thing to actually be able to see these things that has been achieved in the Vega experiments. And I believe you guys can play a role in observing these in the ultrasonic, what I call ultra experiments, which are very, very affordable. So I go down the bottom here and I talk about this experiment and how things could be formed and historical research. And I think at the bottom here I talk about all kinds of different experiments. So Tesla, I talk about Mexican alchemists, and I've got a link there. This is non-exhaustive, and I'll probably rewrite this blog with all of the intervening material in the last 3 years in terms of just really nailing it. But you've got natural lightning, I put at the very top here. Make and break in a bolt, make and sustain in persistent ball lightning. So this for me is, I'm not showing you the image, am I? Sorry. Right at the bottom of this blog is a non-exhaustive overview of some new fire embodiments. And so I go through this, but right at the top of the list is natural lightning. Making and breaking in a bolt, making and sustain in a persistent ball lightning. Organic life, I believe, synthesizes and captures and uses very small active agent. Now, coherent matter works at any temperature, and I believe that we are doing this in our body, and seeds do it in their cells, and there is evidence for both in the literature. So when you understand that you're not having to create something at absolute zero to get it coherent, and you're not having to put things into a tokamak to confine them, it's self-confining, and you just have to set up an environment where everything can be exactly the right temperature. Oh God, isn't that interesting? Because like the body's got a very, very specific temperature, hasn't it? And then you then have very specific chemicals in play. I mean, you know, we're salty creatures. Is there a reason why we use sodium? I don't know. Maybe there is. Why do we have potassium in there? I don't know. But you start to think about all these things a little bit differently. The Mexican alchemists, they put their stuff in the sun for a very long time. Why did they do that? Well, we know that there are natural active agents that are coming from the environment. That has been shown in Alexander Parkhomov's book Space, Earth, Human, and I think Perovchikov in 2012 was shown with 0.4 Tesla magnet field. He can accumulate that in water, and I think what they did is they had these copper bowls. Interesting that we're using copper, and that they put water and they put that into the sun, and that was important in their sort of gold making. You have Tesla coming from a dry environment. This is because dry has static. Static leads to exotic vacuum objects. Henry Murray in the Utah environment, dry static. Boris Bolotov, I talk about him above. Joseph Papp. I'm going to deal with the Papp engine. It is the same technology. I'm going to be really dealing with that probably in my blog series. What goes up must come down. And I think it's quite easy to understand. It'll be easy to understand how Papp's engine worked. George Oshawa I've talked about before. John Hutchison. I think when you take on board what's been said over the last several days and what I'm going to say today, I think John Hutchison's technology will be relatively demystified. We've already talked about the shielding of mass and inertia within the coherent matter systems. Ken Shoulders, obviously, Alexander Chernetsky, Pons and Fleischmann, obviously, and I talk about their singularity here. Francesco Piantelli, I've talked about that in the last few presentations. The original Canon patent from, I think, whenever it was, 1989, I think it was even maybe very, very early. It's like one of the first patents. The German patent and so on. So anyway, there's a whole load of things here where I've gone to some length to explain here. I said here, Suhas Ralkar made, grew and stored active agent in metal fuel externally. I can't change this document. This document has not been changed in over 3 and a bit years. So what you are seeing here is how I wrote about it and saw it back then. And this was not very difficult for me. I just had to pay attention to what Ken Shoulders was saying, having observed the work of John Hutchison. Okay, and so I give a whole series of one there, and I talk about the Lion reactor there. Okay, so that's it. That's all I want to say on that. Now, in the presentation I gave yesterday, which I have here, I referred to 2 authors, or a number of authors, but specifically I was referring to Roger Stringham, who really pioneered sonofusion. So sonofusion is using sound to do fusion, and it's this whole star in a jar type thing where you might focus sound into a spot, and then you would get this glow in that spot, and it's because you get cavitation bubble and collapse and so forth. And so he started out with that, but then he moved on, and he worked out of Hawaii, I believed, and so forth. But and then it was Roger Stringham. So I want to show 2 things, and it's off the MFMP's reaction calculator. So if I move this over, you can see this is at nanosoft.co.nz, and I worked with this. Sorry, not that. We'll come to that later. I worked with Philip Power in New Zealand on this, starting with the work of Alexander Parkhomov, and if you click on the notes there, you can see the development of this and all of the features and what all the features mean, and how to do cascading reactions and so forth. We'll come to look at this to do a test later. But in the bottom right here, you can see this Select Lena Events database, and this is an initiative that was set off by Philip Power himself. I've been working with him on this, but essentially if you click on that Select Lena Events item there, it comes up with a sort of search field, set of search fields here, and we can type in here surname of one author, can leave clear, but I'm going to type this in. I'm going to type in Stringham. Okay, and I'm going to do refresh pre-filtering. And so this, for some reason, has not given me anything. Am I not online? Am I not online? This is not so good. Am I not online? Or have I spelt it wrong? No, I have spelt it wrong. That's why I need an N there. Okay, I'm not going mad. Let me out. Okay, so what you can see here is if I click on this, you can see a whole series of articles here. And the 2 that I'm going to be referring to today are, let me find this. I think it's this 2012 article, and I believe this was actually presented, ironically, not ironically, but incidentally, at the ICCF 17, the first one I attended. So at the beginning of my journey, Roger Stringham was already saying this, so bear that in mind. And it's Model for Electromagnetic Pulsed Bose-Einstein Condensate Experiments. And then the second presentation I'm going to refer to today is this one here from 2019, and it is with Tom Claytor of Los Alamos National Laboratory and Roger Stringham, and that's cavitation effects in various metals in D2O. So if you, for instance, click on this one here, not all cases, but we've got some people, and if you want to help with this database to add links in there, then please send us a message on the project's website through the contact form on quantumheat.org. Anyway, down here you can see the link, and this goes to the relevant part of the ICCF. I think it's ICCF 17 that it goes to. But what I've done is I've grabbed the relevant sections that I'm going to talk about tonight into some PDFs, and then I'm going to walk through that. So, just to recap, these are the structures that we were talking about yesterday, and I'm going to show you those in a little while, but I want to go forth and talk about this. So this is, I believe, from a presentation and from 2012, and so I'm gonna walk through a bit of this because I think it's very important to do that. Okay, before I do so, are there any questions at this moment in time? Sorry, I didn't get the switcher moving in the right place at one point, so just see if you got any there. Anyway, did everyone have a good Easter? That's what's so important right now. Okay. Thank you, Bernard. Okay, you can use this time if you want to go and have a look at the Lena Events database and download these documents so that you can be able to look at these as you like. I am going to change some of the pictures behind me. I want to put the Orion Nebula up and some other images that we've taken over the years, and some that I have to share with you still yet, which are just absolutely breathtaking. Just breathtaking. Oh dear. I just had to deal with this strange radiation thing, get it out of the way first. Okay, all right. Okay, so I'm just going to get on with this. Right. So at the point of him writing this in 2012, he's been working at this, as he says here, over 20 years. And he says, over 20 years of work, including thousands of experiments, have contributed to explanation of the puzzling and disjointed aspects of sonofusion technology. Using new analytical techniques and data interpretations gives a fresh look at sonofusion process at megahertz frequencies. Bear that in mind. Among the resolved problems was the target foil destruction associated with kilohertz low frequency problems. So for most of his research, he was using exactly the frequencies that you get out of one of these little puppies, okay? And he says, as time passed, it appeared that Bose-Einstein condensates in the form of nuclear condensates would lead to paths that resolved some major problems, things like radiation emissions that don't exist. The high densities required to produce the products of alpha particles and heat in sonofusion are similar to the densities of muon fusion. Conditions found in astrophysical steady-state systems can be drawn from to help explain what is a very transient terrestrial environment. It might be expected to exist in a picosecond time frame, culminating in a single alpha particle event per implanted cluster. Okay, so if you remember, Suhas Ralkar called his technology RUBIT, which was resonant ultrasonic something ion implantation technology. So he was learning, I think, from Ken Shoulders and from Roger Stringham. Okay, so but Roger Stringham was convinced that this was just producing article, or at least he only discusses it in this article. Sonoffusion in the megahertz range uses a 20mm disc piezo driving the deuterium oxide cavitation, that's heavy water, bubble process. The red acoustic wave amplitude, QA, P plus to P minus, you'll see it in the graph below, finds a resonant bubble, blue RI bubble, and this is in figure 1. Within the microsecond cycle, the bubble grows to R0, then violently collapses to RF dark blue. The emitted photon pulse, sonoluminescence, SL for short, shown in green, originates from many RF. These are these small things. So he has these the megahertz D2O cavitation bubble cycle and violent adiabatic collapse. So you have this bubble that gets produced, it travels along here, you get an adiabatic collapse, and then it produces these little things. And you can look at this in your own time, but essentially it produces what he calls the Z-pinch jets, which is what Leclerc calls the reentrant jets, with the sonoluminescent plasma, which is marked as green. Z-pinch jets implant the target foil, producing DD fusion. So essentially you get these many little bubbles, they come together, then they cause this reentrant jet that fires this cluster of material into the palladium, and that has deuterons and electrons in a structure that you will see. This is the theory, and that has a self compression, and you get a fusion event which breaks the structure up. That's where he was. Okay, so RF, you've got bubbles 10 to the 3 to 10 to the 5, and they're marked as red stars in here. So they're very large clusters of these little bubbles. An expanded view using the larger knowledge base of low-frequency resonant bubbles, 20 to 40 kilohertz in water and heavy water studies, is extended to higher megahertz frequencies of heavy water bubble systems. So basically, his work was in the same frequencies that we are using when we are using these domestic ultrasonic cleaners. And he's saying that everything you see in this presentation is valid for your home domestic ultrasonic cleaner. Okay, the general piezo bubble mechanics holds for all frequencies studied. Coincidental to the sonoluminescence emission is the RF bubble formation of a Z-pinch jet that is located close to the surface of the target foil lattice. The jet is a partial plasma that is squeezed by sheath electrons, accelerating and squeezing the jet's contents to higher densities before implanting into the lattice. The jet formation from bubbles is well known, and damage to water handling mechanical devices like pumps and propellers is common. And so yes, reentrant jet here. Okay, so how they did this to look at this isn't part of the experiment that you can consider doing yourself if you are going to try these ultra experiments. And what they did is they had a black felt light-proof box, and they used that to look at the sonoluminescence and gear that up so that so basically they had a black felt lined light-proof box so that sonoluminescence could be monitored. And so you could have that, but also you could have a camera in there, because when you look at his devices, it's not really suitable to have a camera in there. But it is with the type of experiments that was proposed by myself at the end of 2019, and I was talking about yesterday. And you could also have potentially a spectrometer in there, which I think we can do. So let's see if we can do that. But anyway, you can see this device is extremely small here, and these are the parts and the circuit board to drive it, and so forth. And he's talking about 1.6 megahertz here, and I'm going to skip past this because there's a couple of key points that I want to pull out here. The heavy water photon intensity was 10 to the 9 per cycle, and more diffuse than single bubble sonoluminescence. It has an order lower intensity than in water, but was not visible to the naked eye. So you couldn't see this with the naked eye when you're using these high frequencies, but when you're using lower frequencies with water, you, in theory, could see it with the naked eye. I think he's talking about the sonoluminescence, where you've got all of the sound focused into a single point in the center. But anyway, there may be a chance that people could see sonoluminescence with the work that we are proposing. Okay, so the favored 1.6 megahertz piezos run at 50 watts from the wall QI rather than 20 kilohertz at 600 watts. Okay, and they produce in 10 to the 4 smaller volume 100 times more bubble. So it's higher frequency, but in much in like 10,000 times smaller volume, they have 100 times more bubbles, and the mechanism is the same, which have the same energy density of the low frequency system. The bubbles collapse adiabatically, producing the dissociated plasma of D2O. And remember what Ken Scholder said is that all you need is to have charge separation and you will have exotic vacuum objects forming. At the collapse of RF, the sonoluminescence and reentrant jet are produced. The velocity of the Z-pinch jet sheath electrons generates a magnetic compression. A Z-pinch. The magnetically compressed Z-pinch jet transmits the dense plasma, implanting deuterons and free electrons into the target lattice, forming the concentric condensates that will be shown later. Concentric condensates. He's definitely calling it a condensate. Okay. Coincident with the Z-pinch jets is the sonoluminescence monitored with the MPC and suggests the condition of the plasma via SL photon intensity. So what you're looking at here is a schematic. Just to explain it, you're seeing part of the schematic, but he is saying effectively there's a Bose condensate of deuterons in the core, and then he's got a part of the outside condensate, and you will see in the text below that this is actually spherically surrounding the spherical core. That's the concentric nature, that there's a partial slice through here, and that the condensate around the outside is an electron Cooper pair condensate. Cooper pairs forming bosons, Bose condensate. Bose condensate on the outside, Bose condensate on the inside. Top is the cluster implosion image and EM pulse energy of the two concentric charged particle condensates that form the two concentric condensates of D plus ions, that's one proton and one neutron in a deuteron, and two E minus, a Cooper pair. Blue balls represent Cooper pairs and orange balls deuterons. Okay. Everyone with me right now? Everyone with me? Okay. So, cluster EM compression pulse. The reason I'm doing this is because people don't think that maybe you can do fusion in this particular device. What I'm saying is this is what Roger Stringham was doing for 20 years using these kind of devices, and he observed fusion. And what you're going to see is that it isn't just fusion of two deuterons to helium in the work of Tom Claytor. Replicating that work, you will see there is a much broader spread of transmutations, and we'll move from that point onwards. So the EM-driven implosion of the sub-nanometer deuteron cluster is represented as a spherical cluster of high-density orange balls up here, figure 4, with the surface interface area 4 pi r squared squeezed in by an equally high density of free electrons. The electrons, the violet balls that we saw earlier, spherically surround the deuteron cluster, and at these extreme densities will likely be coupled as Cooper pairs, i.e. bosons. These densities will form a free electron condensate phase that squeezes the interface surface with Coulombic plasma pressure power. For a time period of less than a picosecond, these particles move towards their common center. This is a self-collapse process. And this is not the first time this is suggested. This was suggested by Takaaki Matsumoto in the early 90s. This was suggested by S.V. Adamenko and Vladimir Vysotsky in the early 2000s. For a time period of less than a picosecond, these particles move towards their common center. The EM pressure power pulse increases to values in spherical symmetry equivalent to those spatial separations in the muon molecular ion. The density is high enough to allow for one destructive fusion event, and this is what is measured in ejector sites. Okay, so the conversation I would have with Russ George was, we see these ejector, they are showing the amount of energy that you would get from a deuteron fusion, and that's that is what's going on. this is focusing on deuteron-deuteron fusion. However, you will see, and it was interesting because if you look at the corollary, not the corollary, but the comparison between the level of certainty here in this paper and the early years of Takaaki Matsumoto, when he was convinced it was quad neutrons that were decaying and causing the events that he saw and the traces that he saw. He progressed from that point to 2001 saying actually it's a vast number of nuclei that are going in, and they are coming out in a range of elements, and predominantly things like calcium and carbon, but predominantly carbon actually, regardless of the ions going in. And this is where this work is going, and therefore it can't just be a simple single event that's occurring inside these coherent matter structures. There is no chemical activity at the interface, as it is too hot and fast for deuterium atom formation. The deuterons and free electrons have the same compressing acceleration at the interface. The magnetic fields and forces are tangent, i.e. you've got the sphere and you've got something coming out like straight like that or in, to the are tangent to the interface and surround the cluster's compression space. The magnetic fields cancel and at the interface with equal compression collapse velocities. The E fields, green and blue, this is in the diagram above, from the blah, 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 blah. The picosecond EM pulse at the interface is compressed by an increasing like charge cluster, compressing pressure at the interface, but it is eventually overcome by the increasing repulsive pressure. The EM pulse reaches a critical fusion density before the pressure pulse collapse. The adiabatic compression heating of the cluster is reduced by the loss of the surface deuterons, evaporative cooling, la 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 la, and I want to see, and then basically saying that at the end the remaining things that get ejected revert back to D2O. Okay, so I just want to show you these images, because these images are all of experiments that were conducted using devices that were operating in the frequency range of this device that I was talking about yesterday. So in the top left here, this is an SEM photo of a palladium target foil with multi-size ejector sites, and this was a frequency of 20 kilohertz. Figure B is an SEM photo of ejector site detail from 5A, the previous image, and this is a photo by John Dash, and it's using 46 kilohertz. The one down the bottom here is an SEM photo of palladium target foil, multi-ejector sites, frequency of 46 kilohertz. And the one on the right is this ejector site here, and it's a close-up of that detail. And again, the photos by Jane Wheeler. Okay, so he is specifically saying here that you can achieve fusion using this type of ultrasonic frequency. And down here, there's a couple more here. And I think this is interesting for a couple of reasons. But anyway, this is using the 1.6 megahertz transducer. And the argument here is that it's a much smaller area, and you can see many pits. And in fact, they've taken a very small area, which they say is a 1 square micrometer, and you can see many ejector sites within that 1 square micrometer. And the size of the pits, they're saying, is due to the fusion event, and you can calculate it from the amount of displaced material. What I like to say is that it looks like there's some sort of track on here with some periodicity that was not mentioned. Is this a strange radiation track? Maybe. Okay. Is anyone bored yet? Okay, yeah, this is compression technology. Okay, okay. The image charge of 2 deuterons and Cooper pairs. At the accelerating interface, both deuterons and electrons accelerate together to the center of the cluster. Residual concentric spherical magnetic fields with the same center are sandwiched at the interface between the 2 condensates in compression, with a large difference in their respective permittivity. That's the symbol for permittivity. The image charge system provides an alternate mechanism to the EM pressure power pulse for reducing deuteron separations. Under the conditions of high density, charged particles across the interface of large permittivity differences, these like charged particles become attractive. So therefore you have this self-compression. The implanted imploding clusters consist of two concentric Bose-Einstein condensate Cooper pairs and deuterons. These two particle groups have relative permittivities proportional to their mobility across their mutual surface interface, from figure 4 top. The electron cluster has a relative permittivity of ES, and the imploding accelerating interface of the deuteron Bose-Einstein condensate has a permittivity of E. At the interface between the two condensates, the ES over E ratio of the relative permittivities is 10 to the 3, so 1000 based on their relative mobilities. Okay? And he then says a picosecond duration of these densities is satisfactory period for the DD fusion to occur. Okay. You can read this in your own time, but anyway, there's a couple of key points that are in the tail end of this, and then we'll go to the Stringer paper, because the Stringer paper goes into more findings, and I think it's specifically relevant to things that we are seeing. Anyway, the nuclear and electronic condensate environment. These condensates, in this case, are different, and not like the more often discussed condensate of cold boson atoms. Remember, when I started this discussion in the sort of third quarter of last year about coherent matter waves, I was saying that I think it was 1996 or 1994, the first Bose-Einstein condensate was formed of probably, I think it was some sort of cesium or sodium atom, or atoms rather. You cool that down to absolute zero. What they're saying is that this is not like the Bose-Einstein condensates, the way you're cooling it down to absolute zero. This is at a higher temperature. The cluster is self-focusing layered spherical collection of bosons, deuterons, and Cooper pairs. For a picosecond, there are no associated electrons inside the interface of the cluster during the electromagnetic pressure power pulse. The cluster is expected to have the properties of a deuteron nuclear boson condensate cluster. The cluster is squeezed by the exterior Cooper pair condensate. So he is specifically saying you have a spherical object, and on the outside you have an electron condensate. Okay? And if you have a Bose-Einstein condensate of some type of matter, in this case you have two electrons forming a Cooper pair, they lose their identity. And so if you have two forming one, it loses its identity. But then if you have a trillion around that, it loses its identity. I'm saying that I believe that it's acting as one coherent body. As the separation between the femtometer-sized charged deuteron particles is decreasing, the two concentric condensates have a very high critical temperatures, Tc, across their interface. This is not cool. This is coherent. The uniqueness of the deuteron condensate character is outlined here. The deuterium atom, after removal of one of its electrons, is a single charged boson nucleus. I've said this for many, many months, years, that deuterium is easier to work in LENR because the nucleus is already a boson. Okay, the deuterium atom, after removal of blah blah blah, is a single charged boson nucleus and is unique in the family of particles at 2.14 femtometers. Its nucleus is the most easily dissociated. The deuteron has only one measured energy level, its ground state E0. The deuteron has a large E1 to minus E0 energy level separation greater than its dissociation of 2.23 MeV and supports a high Tc of millions of degrees. Millions of degrees. A picosecond environment of compressing condensates produced DD fusion events with no measurable radiation products. Why? Why? Well, I've already said why, but why? The energy levels are nuclear, not chemical. So essentially what they're saying is that the coherence in both condensates is maintained at the interface in millions of degrees. So we've talked about Bose-Einstein condensates at absolute zero. We've talked about them at room temp. We've talked about them at 4 Kelvin with the original finding in August 1989 by Francesco Piantelli, the discoverer of the nickel-hydrogen system. We talked about them in a range of different materials at various room temperatures and ambient temperatures of John Hutchison. And here you are literally at the other end of the scale. This is a self-organized, self-compressing thing where the coherent matter is in the millions of degrees. Okay, so the DD fusion in the cluster. The deuteron cluster's compression movement during a picosecond approaches 10 to the minus 12 meters or closer, a separation that is similar to that of the muon fusion. The heat of fusion in a disrupted cluster quenches the potential for the 24 MeV gamma. The information gathered from SEM photos of target foil damage at low frequency between 20 and 46 kilohertz, what we are talking about in the ultra experiments, shows extensive foil damage from multiple fusion events. Some larger 10 micrometer ejector sites from the low frequency piezos show many submicron spheres of recondensed vapors of target foil in the ejector cavity and a few single fusion events. The megahertz exposed foils in figure 5 show a trend to much less target foil damage and many more ejector sites, all of the same energy. The energy on the megahertz exposed foils showed these sites. Now, the interesting thing is, it's saying, and many more sites, but all of the same energy. Now, if it was always one fusion event, why would you get what he's describing, large volumes of material that was melted? Is it actually more than one fusion event when you're looking at the lower frequency? Is it a larger cluster that's constructed? The energy on the megahertz exposed foils shows these sites. Figure 5F are 20 plus or minus 10 MeV ejector sites with a single event of 1 alpha particle per cluster. Okay. Cluster's ejector site at low frequency. The cluster's single DD fusion event is generated during the picosecond after the Z-pinch plasma implantation of deuterons and electrons. Fusion products and debris are ejected into circulating heavy water. The ejector site and ejector size and depth are shown in the SEM photos. A survey of the size distribution of ejector sites in the PD target foil exposed to 46 kilohertz of cavitating heavy water are shown in figure 6. So they've got some information here. Sub-nanometer transient clusters will fuse when compressed to produce fusion heat, QX, and for helium with no measurable neutrons or gammas. Sonofusion does that. And so this is on a 46 megahertz palladium target foil. And so if you're wealthy enough, you can maybe try some palladium, but probably better to take their approach. The megahertz cavitation of argon gas saturated heavy water produces transient spherical condensate deuteron clusters that drive the cluster's interface like a spherical piston into the DD fusion mode. Condensates of deuterons and Cooper pairs and their subtractive atangent magnetic fields and their respective perpendicular additive electric fields form a spherically centered dipole pulse. Both Cooper pairs and deuterons on either side of their common interface accelerate to the cluster's center during the picosecond compression pulse. In these extreme high density cluster compression environments of Cooper pairs, 2 electrons will be favored over 1. Some deuterons will ultimately fuse, destroying the cluster. At that point, he's saying some. So, anyway. He's saying that the deuterons get to a density of 10 to the 36 deuterons per meter cubed. Right. This, I think, is probably the most important experimental piece here in this presentation that I want to draw your attention to here. A superconducting environment. What is that? A superconducting environment. That is the coherent matter electron sheath. That is the coherent matter surrounding sphere around the deuteron cluster that is superconducting. Why is it superconducting? Because it's what Shoulders calls fluidized electrons. It's what I would believe, because Shoulders said this. He says you can change the charge from 100 billion to 1. And if it's doing that, then it's losing its identity as individual electrons, and they are becoming one big electron. And I'm saying that that's what's happening in ball lightning, but rather than it happening around the deuterons, it's happening with whatever, and it's this sheath, this very thin sheath that we saw in almost instantaneously cutting the tungsten wire, but only on the sheath boundary layer. And I believe that it is this coherent matter that is, whatever shape it is, bear that in mind as we go to the rest of the presentation, whatever the shape the coherent matter structure is, it will leave its mark effortlessly. And I've said that if you look at these water cavitator devices that supposedly produce excess heat, and people were driving around in cars with them, and there's a famous story about that. I can't recall, but someone can put it in the comments there. I believe that they're creating coherent matter structures, and the coherent matter structures are effortlessly splitting the water, and they're actually gaining the energy as they're doing that to continue to split water. So you get a kind of apparent over unity, but it's actually kind of like a rectification of the energy, and so there we go. But anyway, he's saying that a superconducting environment rejects any radiation mechanism. A superconducting environment rejects any radiation mechanisms. Now, when I was looking at the Bogdanovich work, and this is from, I think, 2009, and it's shared on Moscow Nuclear Physics University, he shows these tori that are coming out of plasma flow discharges, and some of them are kind of like white, and some of them are black, and you can have a plasma pinch behind the black tori, and you don't see any light through it. You do not see any light whatsoever through that tori. Now, is that similar to what I was showing you yesterday with these little things that are moving around on the surface? If it's stopping light, what is light? Well, light is an electromagnetic wave. And if you had some fusion happening within a coherent matter structure that is superconducting, and it's effectively acting as one electron, when the light comes out, it's effectively shed between the whole structure. And so it's basically a force shield, the force in this case being light. And so you could actually imagine if you had this type of coherent matter structure over, in a field around your spaceship, let's say, and you fired a laser beam at it, the laser beam wouldn't go through it, would just hit it and go okay. But you're thinking about that from the reverse. The energetic effect is happening on the inside, and it's trying to shoot the gamma ray out, but it hits the coherent matter electron condensate on the outside, and it just goes around the outside. So this is kind of how you can imagine that the radiation is not getting through. Okay, solar fusion's energy future can be viewed as high-impact energy technology that may eventually replace the need for hydrocarbon-based energy providers. Clusters and smaller clusters and higher megahertz frequencies show a promising future for sono fusion. This is a changing model for sono fusion. Okay, so with that in mind, we're going to see what happened. This is in 2012. We're going to see what happened with the Tom Claytor, who formerly worked at Los Alamos National Laboratory, his replication of this megahertz plus type experiment, because it shows some revealing details. Does anyone have any questions at this stage before I go and look at this? And by the way, to get to this, you can go to the LEN events database here, and you can go down, and it's this one at the bottom here, where he's down the bottom here, Tom Claytor and Stringham from 2019. You click on that, and then you will have your link down here to go and see this presentation, which I'm going to show you here. And I must thank the organisers of the ICCFs, and particularly Jean-Paul Barbarian, who works unbelievably hard to put all these papers together, like herding cats, and the editors of the ICCF documentation that I'm talking about here. People you may well have heard the name of: Peter Hegelstein, George Miley, Michael McCoubre, Xingzhong Li, and Edmund Storm. So thank you guys for making this available to the public. Okay, so Any questions at this stage? Okay. So can't we just electrolyze water to get some H2 and detonate it with high impulse charge? Stanley Meyer's device, I believe, was creating coherent matter bubbles, and the coherent matter bubbles were enabling excess splitting of water. Or fusion events, whichever way you look at it, it's the same thing. You've asked one further back. Sorry, Jason, I missed it. What was your question, Jason? Answer it. Ask it again. Hi, Paul. Good to see you here. What useful duplications might be attempted by others? Please go and look at the long time no see, by the way, Paul. Go and have a look at the presentation yesterday. I think by the end of this presentation, if you haven't seen the other ones on the Vega experiments, please go and have a look at that. But I think for me, after I've done the Claytor Stringham paper here and Fowler paper here, I think I'm going to show you that what we are observing in the Vega experiments are coherent matter traveling waves, and I think it's essentially conclusive in my viewpoint. And I'm willing to be wrong, but I'm not willing to be right and wait. I just had to get it out today. So oh, good, excellent, Paul. Well, basically, you need one of these to do this experiment, and these cost $25-$35. And go that way, and at some point we are going to be making public the experimental details for the Vega experiments in a fashion that people take responsibility for their own safety, because it's dealing with high voltages and gases. So okay. All right, so I'm going to go on with this next presentation. I've got less to say on this, which you'll probably be pleased about, but I wanted to clear up, because there were some questions following my presentation yesterday about aren't these just little bits of dirt that are moving around and bouncing along the surface? And yeah, it could be, but there is a long track record of proven transmutation in ultrasonics, not only with the work of Roger Stringham, but also with Leclerc and other parties, and we have observed it with the work that was done by Suhas Ralkar, and for me that started my strange radiation journey in the middle of 2017. Anyway, so we will go back to this, and so this is cavitation effects on various metals in D2O, and again I said this is from 2019, and this was presented, or the presentation was made at ICCF 21 in Colorado. And so we'll start off. Cavitation at high frequency in close proximity to metal surfaces. This is exactly what Leclerc would say would produce your ideal conditions for a reentrant jet, was investigated in heavy water. A new miniaturized cavitation system was operated at 1.7 megahertz and was small enough to fit into a sensitive Seebeck calorimeter. The 1.7 megahertz reactor was designed to hold 20 grams of heavy water or light water. The cells were operated in a pulsed mode for 1 to 2 minutes. These are not long experiments, and they're not long when you're using the domestic ultrasonic cleaner, and then allowed to cool in the calorimeter. Target foils were placed in close proximity to the transducer, and different foils show a maximum of about 13% change in measured excess heat output. Tritium measurements were made on the resulting liquid and showed a small initial increase. However, longer runs did not show a linear increase in tritium and the cavitation times were increased. No detectable signals were measured on a pancake gamma detector placed below the cavitation cells. Many different target foils of this scale were run in the system. A few showed some interesting surface features. Okay. Cavitation damage on metals in water is well known. Less studied is cavitation damage in metals immersed in D2O. So for those with a bigger budget, they can do this same experiment with D2O. And if they want to follow the work of Roger Stringham and Tom Claytor here, they can look at the design, and it's fairly simple to build if they want to take it to another level. But I think what's great about this is that we have the ability to potentially video the little critters in action, which may not be as simple as being discussed in the previous presentation from 2012. So the cavitation threshold in an ideal fluid is thought to be very high, about 800 watts, greater than 800 watts per centimetre squared, at the frequency used in this study, the 1.7 megahertz. However, our liquid is less than ideal because the target metal and transducer will shed oxide particles, and in addition there may be nano cavities in the liquid formed during the cavitation. Thus the cavitation threshold is lowered substantially to approximately 20 watts per centimetre squared. Now I've just got a bit of curiosity here. This is scanning electron microscope images were made with the T-scan Vega. Okay, now this is in part the reason why I called the Vega experiments Vega, because the T-scan Vega is a scanning electron microscope, and it is actually made just up the road from me here in Brno. Here you can see the address. T-scan Orsay Holdings, and it's literally just a few miles away from where I am. And we were using a T-scan in our first initial looks at the Lion reactor and at the Echo fuels. So there's a little bit of historical Easter egg in this, and as to why it was called called Vega. But anyway, he was using a T-scan Vega, and actually a large proportion of the world's microscopes are actually made here in this city. And Tesla T-scan came out of Tesla, and in fact if you go to the museum, this is just a complete aside, if you go to the museum, the engineering museum just up the road from where I'm sitting right now, it's literally 10 minutes on a tram. They have the most beautiful SEMs you can ever imagine. They look like 1950s cabriolets. Anyway, so he's using this T-scan Vega. Sorry for that. I just wanted to put that in there. And that's the experiment. These are the little devices. You can see they're quite small. On the right here, you can see they've got the foil and they've got it suspended at an angle between some supports here. So you can see this is it enables the use of a small amount of material and a small amount of D2O, which is probably what you want because it's not cheap stuff. Okay, so now did I actually? Oh yeah. The point that I'm drawing out of this presentation, this particular paper, is this. Figure 4 is an SEM image of a silver foil that had been run under similar conditions to the palladium silver foil 2% foil. So it's a palladium with 2% silver, I guess. It can be seen that a large consolidated clump of material is in the center of the foil, where the acoustic intensity is expected to be highest. Now, bearing in mind, in his experiments, they have a cylindrical resonant cavity, and this means that your half lambda has a resonance in the center, and your n plus a half has one either side, and then as you go up through the frequencies, it is always going to be the center that has the sum of all the most intense frequencies plus the lowest frequency that is resonant in the cavity. In these devices, which have a non-cylindrical cavity, you have all kinds of modes in there, and so you can imagine that there isn't necessarily the same level of focusing in the center, which you'd want really in a cleaner and not something that you want to transmute stuff with. But in another way, it allows for things to drift around and maybe gain more intensity in pumping them with energy. If they're a condensate, you pump the energy into the condensate, into the condensate, into the condensate, without destabilizing it. So it might actually be better in some respects, but then you guys can work it out. Okay, so here is this blob that they found, and there's some cavitation damage over here, and they removed this blob and found a big hole. So something had come through would apparently have eaten some of the target foil, which is mostly palladium and some silver, and it's in some deuterium, and produced this item here. Now, why is this interesting? Well, they observed sodium, potassium, aluminium, calcium, magnesium, silicon, chlorine, sulfur, and phosphorus. Okay, now what I've done for you here is I have, oh damn, sorry, I haven't even I'm not showing you the image here. So I'm showing you here. This is the lump that has come through, and they removed the lump and found this hole behind. So what I'm saying is something was removed from here, something in whatever it was that did this removal, combined with the bit of material that's been removed, potentially has resulted in this feature. And when they analyzed this feature, it found oxides of sodium, potassium, aluminium, calcium, magnesium, silicon, chlorine, sulfur, and phosphorus. Okay, and I want to show you our reaction calculator here, and if you type in the ingredients in the reactor, i.e. oxygen, deuterium, palladium, and silver, and then you type in oxygen, deuterium, palladium, and silver, and then you say I want to see sodium, potassium, aluminium, calcium, magnesium, silicon, chlorine, sulfur, and phosphorus, you see that there are 585 rows, and the deuterons interaction with palladium or silver produce the highest outcomes, and the most high outcomes from calcium. Without going into the details, without coming back to this, they saw no cobalt, for instance, and there is one reaction in this set that produces cobalt, but it produces cobalt with deuterium and palladium with a 30.9 MeV outcome. But there is actually, if you go up and look for 105, here there's deuterium and 105 also producing calcium 46 instead of and nickel 61 instead of cobalt 59, and this has a higher energy yield. And from my point of view, and I've been arguing this for years, that means it's compressing it into a smaller box. You're getting more yield. That is more likely if your thing is wanting to compress into a small box. So you wouldn't see the cobalt because it's preferentially produced these reactants up here that then would go on to potentially do a cascade reaction. Anyway, you can use this and it's the using the 2-to-2 reaction up here. So back to the paper. Here's another example where they had a feature, and this had similar kind of outcome, but you can see that it's a very singular spot and a large lump, and this is in the absolute center of the resonant cavity. So remember what I was saying, if you have a cylindrical cavity, if you go up to the device, it is cylindrical. So in the center of this here, in the center of this here is where they saw this particular structure forming. And so this does kind of imply that where there's an energy concentration, you will get the coherent matter forming. I agree it's coherent matter, and Roger Stringham is telling us it's coherent matter in 2012, and Adamenko and Vysotsky are telling us it's coherent matter in 2003, and Matsumoto is telling us that it's coherent matter and long before that, and so Scholder's telling us long before that. So, you know, you can argue it all you like, but it's coherent matter. And so it's right there in the center. So it matches up with what you would expect. And they have another one here where in the center of the foil, there is a trace that runs across the foil and then goes off at an angle. And it seems to be causing a whole array of little balls of what they say are nickel particles. See, nickel plates that had a stripe of round nickel particles. So something came across this surface and moved around in a location and did some action on there. In addition, some of the particles strongly fluoresced with in an infrared, and then they have here in this experiment where they were using what were they using D2O. Okay, so in the water they found thallium and thorium. Thallium and thorium. Those are heavier than any elements that are in there to begin with. So that is worth noting. It's fusing as well as fissioning. This is not just straight deuterium fusion going on. Similarly, a pure palladium sample showed a cluster of silicon, nickel, copper, zirconium, sulfur, aluminium, manganese, iron, as well as palladium particulates. And if you go down here and you run the equations, you get to see all of those reactants in there. And as I say, if you have deuterium and palladium in there, you get nickel, and you also get copper. So, you know, there we go. Sorry, copper, yeah. And you get these reactants. Anyway, so that's that. Okay. Conclusion. The data presented here indicates that cavitation on metals in D2O and perhaps like water can produce anomalous results that are defined as the Stringham effect after Roger Stringham, who originally investigated these phenomena. This includes the evidence for the appearance of elements not originally present or elements in unusual forms in the system after cavitation. While these supposed transmutations occur also in electrochemical cells, the electrochemical cells contain a soup of chemicals that often claimed to be the source of the impurities. In the present study, the materials are clean foils and pure D2O or H2O with no additives, other than perhaps an argon cover gas. The lack of X-rays or gammas is the most obvious problem when trying to explain the process is nuclear. However, if the energy is less than 10 kiloelectron volts, and in the case of EVOs, controlled to say it's mostly 2 kiloelectron volt soft X-rays, then it is doubtful that the X-rays would escape from the cell. So EVOs produce X-rays that are basically less than 10 kiloelectron volts. Nevertheless, the preponderance of data presented here definitely supports Stringham's claims of anomalous behavior in these systems. Okay. Yes, Ron Muckle, the center is like constructive interference. That's exactly what I'm saying. And when I was talking about the three splats that were on the original indium foil that was serendipitously cleaned and produced these splats in 2019 when I was with Alan Goldwater, those are the resonances in that device, and in the video that I shared yesterday, you had a similar sort of arrangement of resonance. It's not surprising, similar device, I guess. And so this is what you will see. And if you look at Hutchison samples, you've got these great waves, these dips and these mounds. And then within those structures, you've got substructures. So you've got resonances on resonances. And it's when you have the sum of all the resonances, you have the most intense effects. That's where you might be creating your lead or your transuranics. So you don't really want to push it too hard, because you'll end up with the Leclerc effect where you are basically poisoning yourself. Okay. Oh, great to see you, Hank. Okay, so what I wanted to do is clear up those people that thought that it's just normal cavitation, whatever that means, and it's just normal cavitation damage, whatever that means, and so there's nothing interesting going on with the videos. I'm saying there is a long history of observation of transmutation, and we have actually observed it ourselves when analyzing the fuel from Suhas-Ralkar. And if you look at my previous presentations on the matter, we have shown how the synthesized elements could have come from the original elements on trying to fit things into a very small box. And what I've shown you with the Stringham paper from 2012, regardless of the fact he's just saying it's deuterons going in there and the electron condensate on the outside and it's self-compression, it is trying to put it into a small box in doing this. And this is exactly what Matsumoto was saying at the beginning of the 1990s. He started off with quad neutrons, but he agreed in 2001 in Fusion Technology, in a letter to Fusion Technology, that ultimately he realized this is trillions of nuclei that are being compressed at the same time. This is much closer to the thinking that was later presented in 2003 by S.V. Adamenko and Vladimir Vysotsky, where they're also saying a vast number of nuclei are compressed at the same time. And Shoulders would say that what's happening is you're getting a quark soup in there, and then you can get out whatever depending on the end result. And what you see with these systems is large blobs of one element. Like we saw this when we were looking at the water flow discharge foil generation technology of Suhas-Ralkar, where you would get this ball, and on this ball you would have a bit of palladium here, and over here you would have a bit of gold, and then you would have other elements, but they're like blobs. If you look at the exploded spike, I think it's now in Brookhaven National Laboratory, the equipment that was formerly in Ukraine by SV Adamenko. When you had this 1/10 of C discharge from whatever it is, 300 joules or something, discharge, relativistic discharge, you had this kind of like flailing of the little spike, which looks very similar to Hutchison samples, some Hutchison samples. And then on it, you had these areas of like near pure gold, near pure palladium, lead all over the place. And so what you can imagine that there are coherent matter of different intensities, and that when it fails, it kind of like when the music stops, that blob of coherent matter is a particular element, and this blob over here is a different blob of a different element. So you're able to synthesize a range of elements. The irony is you tend to get lead and carbon out of it, but lead because it's the heavier stable element, and this technology, if you've got anything lighter, it will find something in the middle. If you start with light elements, it tends to fusion or fission to carbon. But I've talked about why that is and my rationale, because it's basically an alpha conjugate. Carbon is triple alpha, and dual alpha is beryllium 8, and that decays into 2 helium in a very small time frame. I think 8 milliseconds or something, very short time frame. And then the other one is alpha. So and I've argued that to death. So that's how it is. And so I'm going to go ahead with this argument with the coherent matter. So you have a sphere. Everyone, if you look again at the work of Matsumoto, he's saying you either get a sphere or a torus. And a torus and a sphere are the two structures that have the most volume contained by a single surface and by a minimum surface. Okay, so it's natural that they would form those structures. And the typical soliton that Ken Shoulders is talking about is effectively a pinch of electrons, and then I believe that they are forming condensate, and so that's pinching down and forming that. Those can aggregate together. We've shown, I believe, that some interaction in recent videos of those doing that on video, and Bogdanovich has shown them living for a long period of time and being able to capture those on images after a plasma flow discharge, and also forming crystal clusters that can move around and being able to image those. But I think what's different is we've seen these structures being ejected in the Vega experiments that look like the traces that you see, this great array of linear traces that have these repeating subfunctions on them that has been hitherto unexplained. Now, I believe that we found the structures, but I don't believe that the point that we found the structures, we actually knew what it was. And I believe it is coherent matter that is in those structures, but why is it forming that shape? And if it is the coherent matter, then it can cut through the material as if it's not there. But what is causing these shapes? I presented this image from a Jean-François Geneste presentation that was done at the EADS annual meeting in 2015. And this was actually from a book that was written by a guy called Popov, I think, if I can get the name right, let me get this right, Popov, in 2014. So before I go and show you that, I just want to show you a couple of these kind of wiggly traces. So here's a typical one. What could form this kind of wiggle? Let's go and have a look, see what else we can find. I'm going to go over here. This is an area that we talked about before in this particular video. Let me see. So we got a wiggle here. What is that wiggle? Why is it like that shape? Why is this one this kind of shape where it's kind of like got sharp point and then a curve, sharp point and then a curve? Why? Let's go forward a bit. Let me see, where are we? Hold on. Let's go over here. Okay. So we've got a range of ones over here. Look, we have long ones. We have ones that just look like they're straight. Okay. Okay, we'll go over to the money shot area, which we talked about before. Okay, is it here? Somewhere here, maybe? Oh dear, well, I got it. Where is it? Where is it? Sometimes we're only looking for a few frames, so talk amongst yourselves. Oh, here we go. This is where I think we need to go. Okay, there we go. Okay, so we talked about these ones, and here's a squiggle up here, and let's go down here. This is where the action is. Okay, so we have this trace that comes up here with this curved top and a sharp point, curved top and sharp point. There's another one in there as well that we talked about. We've got the intense spiral here, and then we've got the split spiral over here, but these curves. And then I look at these structures. They're kind of part spiral, but they're not. This one's got a hard edge and it comes down, a hard edge and it comes down. And this is very, very similar to the title frame on this video here. And if I zoom into this, over on the title frame, I selected these where you got this. This is our group that came together and split apart. You've got the wiggles here, but you've got these ones that kind of go down, tie themselves into a knot straight, and then go have a kink. You've got this that comes down, kink to the side, down, kink to the side, down. What is going on? What is going on? Well, this is natural ball lightning. It has a wave mode, and then it has a kink, and it has a wave mode, and then it has a kink. What is going on? How is this occurring? Well, if you look at the actual book, if I can find it, this was sent to me by Peter, and I'm doing this for scientific progress. So you can see the link on the page there, but if you go to the blog, it's there as well. Gallery of two soliton pseudospherical surfaces. So he's done these calculations, and he comes up with these pseudospherical surfaces. But look at the actual traces they make. Comes up, and these are slightly at an angle with a kind of deflection on it. This one goes a wave and then a kink and a wave. These ones got a big wave and then a kink and then a big wave and so forth. And this one comes up, goes round in a loop. This is very much like you are seeing these kind of structures over here. Okay? So what I'm saying is that Popov is very close to describing, not for this case. I think he's trying to just do some mathematics on some surfaces. I may not be doing him full credit here. You can see other ones that he's got here, and these interesting surfaces, which looks like an M with a break and then an M. You know, we've seen these kind of traces. So it's not a surprise that this was selected by Jean-François Geneste. You've also got these kind of structures, which depending on the orientation you look at them, they produce these kind of shapes. Okay, so that's that. But then when this was discussed, Axel on ECAT World, he shared another paper by someone that took Popov's work and extended it. And I want you to see what I'm talking about. So this is topologically embedded pseudo-spherical cylinders. Okay, so I think the class of traveling wave solutions of the Sine-Gordon equation is known to be a one-to-one correspondence with the class of necessarily singular pseudo-spherical surfaces in Euclidean space. Everyone gone to sleep yet? No? Okay, good. with screw motion symmetry, the pseudospherical helicoids. We explicitly describe all pseudospherical helicoids in terms of elliptical functions. This solves a problem posed by Popov. As an application, countably, many continuous families of topologically embedded pseudospherical helicoids are constructed. A singular pseudospherical helicoid is proved to be either a dense subset of a region bounded by two coaxial cylinders, a topologically immersed cylinder with helical self-intersections, or a topologically embedded cylinder with helical singularities, called for a short pseudospherical twisted column. Okay, so he's actually... it goes here, so this is almost like mathematical, just straight mathematical work, but he is talking about this in sort of electromagnetic kind of space. Anyway, I'm just going to show you the images and the paths that this kind of predicts. And you can read this paper in your own time. Basically, I haven't had a chance to fully digest it, but I just felt it needed to be got out. So we'll just go straight down to the images of the so-called solutions, which are down here somewhere. There we go. So here you have the coil, okay? And then you've got this structure on here. Now look at it. Look at what you're seeing here. Let's see if I can go in and look at this green area here. Look, goes up, kind of like semi got a curve, then it's got a kink, it goes around a corner and goes up. Is this not extremely similar to what you're seeing in our Vega image here with these kinks? Is it not extremely similar to what you're seeing in this natural ball lightning? We are saying that ball lightning is coherent matter. That's why it can go through glass and leave a hole. That's why it can go through a large brick wall and leave a hole, basically vaporizing the material or making it go somewhere, or turning it to gas, or something's going on. And I'm saying that that is exactly what you're seeing here. But at the moment, these coherent matter are showing themselves by interacting with the material around them such that they present themselves as a light string. But it's these ones over here that have this change in angle. And so we'll go back to the paper, which is here. Now look at this one. It comes up, curves round, and then straight up. These are the type of structures that we are seeing in the Vega experiments. There's some more case scenarios. Look at this. Look at this curve here. Does that not look like what you're seeing there? Tell me if that... Oh yeah. Let me see if I can find it again. Tell me if this incomprehensible shape here that you're seeing here is not exactly this. Is it this? Is this this? Is this this? Is it this? I think it is. I think it is. Oh dear. Look at this. What is this? It's got a curve and a spot and a curve and a spot and a curve. Where have we seen this before? I think we saw that here, didn't we? What is going on here? What's that? What's that? What is that? Does that look like that? I think it does. Oh my God. Oh my God, look at it. It's that. And I can tell you, this has been replicated multiple times in Dave's experiment and multiple times in Hank's experiment. This is replicatable by independent authors in subsequent experiments. This is science. This is science. And there's mathematical functions that are specifically, if you go up, this on the left here is a twisted columns of magnetic, and on the right, electric. Okay? These structures here. Let's see if we've got any more structures. Look, this is a little bit of a wiggle and a kink, a little bit of a wiggle and a kink. I guarantee you we're going to find a structure like that in our Vega experiments. I don't even have to guess. It's going to be in there because, you know, these are various solutions, but, you know, we got some kinks over here. These are more kinky ones, and you get to see these as well. And here you've got a spiral in a spiral, okay? I've already shown you these tracks, and what I will try and do is I will try and just show a number of examples coming out of the Vega experiments where you have this is the solution to the surface, and this is what you're seeing. Okay, so this is magnetic solution on the left, and this is right, and pseudospherical twisted columns. So you can go and have a, here's another couple of selections, and we've seen these traces. Dave and Henk will know that we've seen these traces. We've got many more traces to share. So now what I'm saying is that these structures in here are coherent matter, and they are waves. We have a mathematical solution to say that this is provably a possible thing in reality for solitons and for waves, electromagnetic waves. And we have matter. Matter gets transported by these things. Matter is interacted by things that produce traces that are the shape of these things, and we've seen them physically on imagery. So essentially, I think it's done. I think it's done. I think these are actually coherent matter traveling waves. You have a coherent matter sphere. You have a coherent matter torus. Okay, those are your basic Matsumoto shoulders type exotic vacuum objects, but they go, as both authors recognized, much further. The tori can cluster into a greater torus. These can then form mesh-like structures, and the mesh-like structure is coherent matter that can self-compress. But if you can imagine, there's a mesh, and then you blow that up, and the tori or the spheres are ripped in such a way, and they fly off in a direction. Could they form these type of solutions as they travel? Are they following an electromagnetic wave, and it is the coherent matter that's following that wave? I don't know, but I am saying very specifically that what we are looking at is, and I have my title slide here from today, I believe we are looking at a solution to strange radiation, and that is, if I pull this up here, oh dear. Okay, I'll switch over. There you go. So I'm saying that coherent matter traveling waves is strange radiation. The ones that we haven't already dealt with, like the crystal type tracks and the straight tori, or the straight kind of spherical impacts. The cluster ones. I'm saying the ones that we're dealing with here are the unusual range of linear tracks. And you know that if one is able to track the other, as we have seen in video, that if one is being pulled along with something else, you will have parallel tracks, or you'll have parallel tracks where there's, maybe one spin going one way and one spin going the other. I think it's pretty much done. So I should have a beer, but I get gout, so I can't have it. Has anyone got any questions? Anyone got any questions? So in terms of John Hutchison's work, I would suggest that he is certainly the samples that I've looked at look like they've got a range of frequencies on there, and so I would suggest that he always had an arc discharge. He had a Tesla disruptive discharge generator. He had an electric field in there, and he used electromagnetic waves. I believe that the electromagnetic waves were guiding the exotic vacuum objects that were synthesized in the coronas around the disruptive discharge unit, and possibly from the uranite that he had in play. and that there was an electromagnetic stress in the ether that was set up, and that in combination with the E fields and the interaction between the E fields would be building up coherent matter in his bodies. And if the whole thing, like a cannonball, gets covered in coherent matter, then the mass inside there gets negated, and so it's kind of like basically moving around like a ball lightning does. It's just drifting on the winds, or it's drifting because of the slight change in the summation of impinging electromagnetic waves on it. So, you know, I think the disruption is fairly evident from what I've shown you. You know, if you have coherent matter, it's going to transmute things, and you're going to, as we've shown with Hutchison material in the past, you have these regular arrays of things which are transmuted, and like in the center, you start off with aluminium, and in the center you get silicon. On the outside layer you get magnesium, and so it's taken. It's aluminium, and then on the outside you get magnesium, on the inside you get silicon in these spots, and that's because aluminium is a fermion 27, and silicon one side is 28, and so that's a bosonic nuclei, and magnesium is a bosonic nuclei. So you get this arrangement. So all of the data points to the fact that this is what was going on with John Hutchison's technology. It is to do with coherent matter wave technology, and the strange radiation is a traveling version of that. When what's his name? Yul Brown had a thumb-sized tungsten electrode and in an electric arc furnace, and he touched it onto his ormus. Maybe the ormus played a role, but certainly what happened is maybe the ormus, because it's has claimed superconducting properties, was able to form a superconducting condensate very rapidly in interaction with the electrons. And that was able to literally eat the tungsten. And he reported that the glassware around his lab, well away from the device, was crumbling. And so you can imagine the flux came out, and Leclerc reported that there were emissions that were recorded in materials around his lab, and so this to me is strange radiation. And certainly in the case of Aroitskev, he was doing experiments with detector materials and iron 57 0.7 meters away from a reactor, and the reactor was an exploding foil in water with a polymer and then steel casing around it. And in the case of the work of Edmund Storms and Brian Scanlan, this was in 2011-12, I think. They had material in a glass, plastic, steel, aluminium, and then they were still detecting something coming out and interacting with the mica, and I believe it was interacting with the fluorine and potassium in the mica to produce some decay, oxygen 18 type decay. But anyway, oxygen 18? No, not oxygen 18. But anyway, a positron emission topography. That one. Anyway, another day. Okay. When and how did you encounter John Hutchison's work? Okay, so the story behind that is a member of the cold fusion community tried to destroy my name in early 2017. I didn't know about it before. I was just about to travel to the UK for a different reason, and my Italian friend told me, "Have you seen this hit piece on you on the web?" And I said no. But on the same day that I looked, and apparently it had been there for many months, there was a comment by Andrew Johnson, and he was defending me. He says, I don't know about this Bob Greenyer guy, but what he's saying about X, Y, and Z, that's true. And so I thought I'd try and reach out to Andrew Johnson because I felt it would be, I wanted to speak to him. And we met that Sunday, 3 days after I found out about the hit piece on me. And through him, I was able to meet John Hutchison, to cut a long story short. And so what I found in this process is that every time someone's tried to prevent the next step from being discovered, they've actually enabled it to be discovered. And it's just been a beautiful thing that, like, they try and throw a spanner in the works, but then by doing that they're pointing out what you need to be looking at. So it's been a wonderful thing. Bye, Gordon. Okay, no worries, you can look at the recording. Okay, I'll see if there's any questions. Okay. How do we turn this into off-grid power? Well, from my point of view, I would look at Ken Shoulder's work, and I would suggest you use the traveling wave design. He has a half bias tube with an Evo gun at one end and the anode at the other. He fires pulses out as the electrons condense. They emit 2 kiloelectron-volt photons. You get photon emission from the half-bias tube. That produces more electrons, which can be condensed, more free electrons that can be condensed, or that can flow with the Evo towards the anode. So you get a net gain, and you just need to provide heat to the anode. And I've suggested recently, and I will draw a diagram about this and maybe a whole presentation on it, that if you made the anode the heat sink for an LED, you could use the electrons to provide the power to drive the LED, and the waste heat from the LED to provide the heat to reconstitute the electrons from the formerly condensed electrons that are in the Evo as the Evo disrupts. I'm saying, someone's saying Bob is describing the fuel. I'm saying that coherent matter is able to do all kinds of things with normal matter. And depending on what you do, you can remediate nuclear waste, which is my focus, and one thing that I want to do as a priority. And that would enable traditional fuel cycles to be safe, and also waste fuel to be dealt with so that it isn't a problem. And then, so that's one thing you can immediately do. The other thing is that you can make elements that you don't normally have in a different abundance. So, you know, by knowing that these things can manipulate matter at the certain resonance or the certain energy, as I said before, I believe that when you have a condensate of a certain size and in a certain set of parameters, it will produce a particular element when the nucleons come back into our free space, as it were. And I've said this since, I guess, my ASTI presentation in 2016. My opinion hasn't changed. I just didn't know what strange radiation was. I hadn't even seen strange radiation for myself. But what you are seeing today is a conclusion of a journey where the last types of strange radiation we can see on video, and we have a mathematical equation that precisely fits the types of strange radiation patterns that you see, which you also see in natural ball lightning movements. Yeah, Gordon's right about electrons one way, positive then out the other way. Let's not rely on anyone else, Jason. Jason Smith is saying somebody has already developed this. Okay, fine. But this is not a mystery anymore. We have a consistent set of data spanning 20, 30, 40 years maybe. I would definitely say that Ken Shoulder's analysis of John Hutchison's work is really absolutely fundamental to the whole understanding. So really this starts with John Hutchison, because he expanded on the work of Tesla. And so I think what you're seeing is John wanted the whole world to see what he had seen, but the thing was, you know, he doesn't necessarily or didn't necessarily know exactly how it worked. And if someone else knew about it, they didn't say it, so they're also rands. Okay, you guys have enabled volunteers in this project and contributors to the project to get to where we are today, and so you can thank yourselves. And we can do it. We can do it. Okay, when you see it's like once you know what I've showed you tonight, the rest is just paperwork. It's just paperwork. It's just like once you know how something can work, and that it is true, and that it is actually a real thing, and that the transmutation can happen, and it's happening for a specific reason, and these strange radiation traces are happening for a specific reason, and it's exactly the same as a natural thing that no one's ever been able to explain in thousands of years, then you can work off the basis that this is a real thing, and that you just have to work out the minutiae. Terraforming baby, yes. And in my mind, I can see, pioneers like John Hutchison, the fact that he was willing to share these really bizarre effects. I would like to see, on some other planet, thousands of years from now, people saying, well, we're only here because of what John Hutchison was willing to share and put up with people dissing him. Okay, you don't have to know how something works to know that it works, if you know what I mean. You don't have to know the mechanism. Like, you don't have to know that there's an electromagnetic equation that explains that these traces that you are seeing. When I show these traces in this, these traces, they are real. This is not guesswork. This is what nature is telling you it can do. And the ball lightning image here is telling you what nature can do. This is not guesswork. This is what it's doing. This hasn't got an opinion. Nature hasn't got an opinion about what can happen in science and what can't happen in science. It just does what it does. And what you're seeing now is that there's not only repeatable science that can replicate these things, that there's actually mass that fits exactly. And the mass wasn't designed to explain these particular observations that have only just been presented to you in the last few weeks. The mass pre-existed them as solutions to equations. Okay. Are the rut tracks in Turkey SR tracks? Maybe. What do I think of black light power? I think that if you have a liquid electrode as your cathode, as Tesla did in 1935 for his death ray, or as the Ken Shoulders did in his 1980s patents for his EVOs, and you have a high DI/dt discharge, you will be forming coherent matter waves, and they will compress anything. This is ultra dense anything. Okay. Now, of course, if you're starting with a material that's less, the same material, i.e. all the protons are the same material. Oxygen is basically all oxygen. Oxygen has a very specific property, and I will talk about that later, but it is to do with magnetism. Go and see if you can work out why I'm going on about that. But oxygen is key to, I believe, many of these systems and ball lightning obviously is in a environment 9 times out of 10 that has moisture in it. Okay, so that will have oxygen in it. So I think that particular Felix Audet, he's referring to BLP. I cannot see a way that they can have their own private universe that does not produce some form of coherent matter waves. I can't, traveling waves. I just can't see it happening. And certainly, I advised, as they were having all their problems, solutions, the best that I knew of, to protect their device from producing these so-called meltdowns. But it's not not thermally a process, really. It's not necessarily thermally a process. It could be the interaction of coherent matter with metals. If you've got too much coherent matter, your metal's going to turn to jelly, or it's just going to fracture. That's just what it will do, or it'll disappear. Yes, so WP Gen Laten for truth. Obviously, there might be a way to say that easier. He's saying that maybe you can produce energy by doing the remediation of nuclear wastes. Yes, I'm not saying you won't get energy out of it, but my focus is to remediate the wastes first. This isn't something that I've invented. As I said, that specifically Matsumoto in 1996 or whenever it was, and hopefully I'll get the translation of that at some point, he presented to a Japanese nuclear conference or whatever, specifically using micro ball lightning for radiation remediation. Okay, there you go. And he's a nuclear scientist all of his life. What I've just been discussing, though, is the mechanism, and that many people had little bits of the puzzle. In 2007, Jason Smith is saying that some bad actors have had a hell of a head start. Firstly, this technology has been used by our species and other species many, many times. For me to go from not knowing anything about this in 2012, other than wanting to solve the energy problem, the waste problem, and so forth, and where I am now, if I was on a planet that was 2 billion years older, would I have learnt about it? Yes, because it's the same science at every point in the universe. So 100% this is known on many planets across the universe. 100% certainty. If you think there is a single organism in the rest of the universe, then I would argue that it will be discovered elsewhere. That's the first thing. I believe that we have used this technology as a species multiple times on this planet that we are living on currently, and I will talk about that on my blog at a later time, and the evidence that's very strong for that. I will then so there's that. At the beginning of 2017, when I realized what this was, I had a choice to walk away from this field. I had a choice, and I thought, well, this is already known. It was probably mostly, at least for the let's break things apart and make them into very small things, and what you might think you could do with that. I think it was probably nailed between the 1950s and the 1960s. It filled me with horror and despair that I had wasted half a decade of the prime of my life on trying to investigate something that people already knew how to do. I thought it's just a mockery of my one life. But then I thought what a real mockery would be is to walk away from it, because they can subjugate us with this. I've talked about this before. They can subjugate us with it. And what we need to be focusing is on the positive things that can be doing with it. And people need to recognize that this is a real thing. Ball lightning exists. Get over it, okay? Find out what ball lightning is. It produces these type of wiggly traces. Why is it producing these wiggly traces? Why are we able to, with Dave's work and Henk's work, why are we able to demonstrate the same wiggly traces and a selection of wiggly traces that no one can explain until we can explain it, which is today. We can explain it basically 100%, and that these produce tracks that no one can work out how, up until this point, you are able to remove large bodies of material in repeatable tracks that seem to be in phase and at the same wavelength. When you are looking at, I've just got rid of the image I wanted to show you. Okay, so when you are looking at this particular trace from Zhigalov, when he was monitoring the work of Alexander Parkhomov, you have these things are essentially in phase, all bar the fact that they started and one curved round a little bit. It went on the outside track, and this had a shorter distance to go, and they are the same width, and they are, you know, the same wavelength. This is born out of coherent matter. Look how identical these things are either side on this track. Okay, it's not coincidence. In fact, it is actually coincidence. But what I believe is a coherent matter structure hit here, where you see the pit, and it divided into two. And these divided segments show this repeating pattern. And this repeating pattern, I believe, is described by these traveling waves. And so it's a coherent matter traveling wave. There we go, done, you know. And in many Dave and Henk videos, you see these structures which all seem to be like they're all moving in the same angle and almost the same distance. I can show you a video of moving structures that are in the plasma that looks basically like this frozen on a DVD structure. And I will do that. Yeah, John Hutchison should be the first man on Mars. That would be awesome. Although it's not good, the low gravity. Okay, I'd like to look forward to W for Truth. I'd like to look forward to seeing your images. You can send a request to quantumheat.org. Mills once told me that transmutations only happen in stars and nuclear power plants. He is wrong. I'm not saying Mills is wrong about everything by any shape or the matter, but you can transmute matter with exotic vacuum objects. Done. You can. Yeah, maybe I'll do a Zoom meeting. It would be great if people could go away and look at some of these papers that I've been sharing. The Andrei Popov one, this Andrei Popov one, this one where we are seeing these beautiful squiggles. It's just, you know, this is what we're looking at. It's just what we're looking at. You know, it is what you're seeing in these things. Oh dear. But here's our trace that we saw. You know, it's come out of this structure here. It hits this point here, and then oh no, I've gone to the beginning. Anyway, that was the one that split up into multiple traces. Yeah, where is it? Oh dear, I've lost it now. Anyway, you've seen it before. Interesting. W for Truth. I think the issue with the infringement on our civil liberties and freedoms and the imposition of the only choice that we have in our one life, which is to what we put into our own bodies, is sad. But I would like to see, you know, we're trying to do experiments. We had a whole set of experiments that we wanted to do last year, and everything's set up, and you know, it's had to be put on hold. But you know, you don't have to waste time, and I think what's happened last year and this year, I think is as valuable, if not more valuable, in many respects than what possibly could have happened otherwise. So you know, don't get mad about it. Just get on with it, you know. Look at this stuff. Look at it. It's just crazy. Look at that one. Woo! Boom! Oh. Done and dusted, LA Flair. Normie academics will be so triggered. Yeah. This project would not have happened if it wasn't supported by the people throughout the entire process, from beginning to end. It was normal people doing it, and you know, Dave and Hank's contribution, Alan Cusk taking me seriously about using a microwave, you know, what do you call it, an ultrasonic cleaner, you know. Just what I applied was that the people that are saying these things, who have good reputations, and this is right from the beginning. Martin Fleischmann was one of the most, if not the most, respected electrochemist in the world. And from the outset, it was like, these guys are not going to put their reputation at risk unless they really think they've got something. And I believe he did. And so I went on the assumption that they're not fools, and they're not trying to make a fool of themselves, that there's something to what they're saying. And everyone along the journey that I've listened to, you know, it's like everyone's got something that they might have seen if they spend long enough doing this. And you know, so it just listen, internalize it, and so forth. But we're at the point where there's a family of experiments that can be readily investigated, and we can learn a hell of a lot for it. It's just, as I said to you in the previous presentations, there is so much low-hanging fruit. It's almost mind-boggling, and that not just in the terms of the behavior of everything that's going on, but also the implications for what it means. Yeah, pneumatech prototypes, that would be great. Let's do that. You want to show the design that you have for your device. Oh, certainly, Gardy Pierre. The human brain is a biological quantum computer. Obviously, yes, definitely, certainly. And it interacts with the entire ether simultaneously. All of us do, except when we're in isolation. But I'm dealing with that on my blog. Look for the next personal blog post, and it's going to be a series. It's 3 in that series. Where does the tinfoil hat go, or when does the tinfoil go? Well, I'll clarify that with Alan Cusk, but I think he was using the polycarbonate of a CD case, and it has often a little ridge around it, and then the foil might be wrapped around there. So in the Clater thing, you could see he was suspending it between 2 supports. So it might be, and he says there's 2 millimeters of water or something above the foil as well. So you know, I think you can try all kinds of things to basically. It's such a quick experiment, and you can fast cycle these things. But I'll get all those nailed and add them to the blog for Ultra, that particular, the last blog to this one. Yes, Jason, some YouTube videos on oxygen and magnetism. The classic one is if you take liquid oxygen and you pour it over a big magnet, it stays between the magnets. Now, I will expand upon that, but it's It has some very, very special oxygen. It's very, very special, and that is why it is so important. TP Sven, wouldn't you get these type of rotating waves if you had a perfect donor EVO that hits something with higher density and breaks up and thereby starts wobbling in a forward direction? I suggested that actually beginning of last year, and I still think that that is a possibility for some of the things that you observe. However, I think that these structures are better explained as a traveling wave, or a large number of the ones that we've been sharing as part of Vega. So it's kind of like there are a whole array of things that can happen. Certainly Matsumoto shared toroidal structures that were broken, and a segment of the toroid is over here on the X-ray plate. So you kind of like had a crescent, a big crescent of the former toroid, and a bit was broken off into the side. So these things can break 100%, certainly. And if you imagine a macro structure, or, you know, like a buckyball structure, and I'll talk about aggregates in a different video when I'm talking about the Vega Valley and how I understand that this is formed. These can break into different structures as well. Would a microturbine fueled by HHO produce strange radiation? I'm pretty certain, and have already shown stuff, that HHO... okay. Certain types of oxyhydrogen gas, the heavy type, and I believe that's due to the oxygen and the cluster nature of it, can produce coherent matter when it is burnt, and therefore it will interact with matter in unexpected ways. But kind of expected when you know what coherent matter can do, and you know what it can do. You just look at Hutchison's work or what I've just shown you tonight. Thanks for your kind words, Ellie Flair. Thanks, NTP. It's specifically the magnetic nature of our oxygen. It's very, very different from all of the elements anywhere close to it. Very, very, very different. Okay, I think I'm probably going to call it a night. So in summary, through the Vega experiments, which you can look at a wide range of them on the Remote View blog and on the MFMP's YouTube channel, we have shown the formation of structures that are observed in nature when ball lightning moves through the air, and that the same structures, hold on, there's a nice one there. Did I miss that? Okay. And that these explain the strange radiation tracks that we have observed in a range of experimenters over the last 30 years, which had not had a proper explanation, and that we've also observed similar things in ultrasonic devices, and that Andrei Popov's work, as highlighted initially by Jean-François Geneste, could explain that, and the extension of that work by, I think it's Italian authors, I'm not entirely sure, let's have a look. Emilio Musso and Lorenzo Nicolodi. They sound pretty Italian to me. I'd wager that they were Italian. They are showing traveling waves, magnetic and electric, which produce structures that are very similar, if not identical, to those that we have observed, like this kind of structure here, and that this leads to transmutation as observed by Stringham over 3 decades, if we can see here in sonnefusion, and that there is fusion at the basics, but the replication work done by Tom Claytor in 2000 presented in 2019 here, if I find it, where is it? Yeah, by Tom Claytor, Roger Stringham, and Malcolm Fowler. This shows a range of transmutation, and that range of transmutation can be predicted by a model that says that the nucleons are reorganized into a smaller box, and you get the outcomes that they observe. And it is said by many authors that this is due to coherent matter, and that the extension of the work of Popov by the Italian authors Emilio Musso and Lorenzo Nicolodi are good fits for the observed type of structures that we see in reactors that use plasma discharge. And so there we go. I think that's about it, really. How did the oceans form? Well, oxygen is the second most abundant element in the Earth's crust. Oxygen is one of the most likely outcomes from LENR experiments because it is it's quad alpha, and the proton, i.e. the monatomic hydrogen nucleus, is the first element that becomes stable in an electronuclear collapse. Obviously, it's the most simple element, and Piantelli proved that, essentially, in my view, a coherent matter structure in his nickel rod 3 weeks after the experiment, and when it was cold in a cloud chamber, is ejecting protons. This means in my view, it's reorganizing nucleons, and there's a balanced proton left over, and it kicks it out. So if you have a range of elements not suitable for life, and then you have, for whatever reason, electrical stimuli producing sparks, that they will, over a period of time, produce protons and oxygen, as well as carbon, by the way, and you will eventually synthesize water. So I don't think you necessarily have to have water coming from the outside of space, landing in comets, and that may play a role, but where did the water on those things come from? So, you know. Yeah, Felix, I'm going to do a presentation on strange radiation detectors. One on protection and one on detection. I've talked a lot about both aspects, but it would be good to have like 2 discrete presentations with the best or most available best understanding of what works in both cases. Thanks, Henk, and thank you, Henk, and thank David for sharing your data. Hopefully after this presentation you can see that what an amazing thing it was for you to have been willing to go public, and what amazing honor it was for me to go through frame by frame the materials you sent over and look for something. And credit to you, the first squiggle was in your videos. It's a shame you missed seeing these kind of structures or sharing these kind of structures first, like this one, because they are in your data as well from the 2nd of February. So they were in your data, I just hadn't seen it. But Dave's data revealed these things to me, and here we are just a few short weeks later, and these are real things that people have already modeled for electromagnetic systems, but more on a theoretical basis for a traveling wave. And I believe what you're seeing here is something that is coherent matter. So well done, well done. ET planets have this tech also more than they're likely. We were getting a lot revealed about it though, the DoD, through the DoD. Myself, Alexander Shishkin, Piantelli, we're all of the opinion that none of us are inventing anything. There are many other authors that are like this. I would agree. John Hutchison is the same. We get this information, and it's not our right to hold on to it. We have to share it. It's just a no choice thing. So, you know, when I got some data back from something I put out into the universe on the ultrasonic thing, I had to share it yesterday. That was my responsibility to share it. I don't have a choice. And you know, I made the correlation between the work of that we were seeing in the Vega experiments, and I had to make that public because I saw the correlation between that and the Klein-Gordon sort of solutions, and because that was shared, then you know someone finds something else, and so here we are. So it's what you have to do. This is for everyone. LA Flare, they may have got this, they may have not. What I can say is we haven't had the imaging technology that can show you this. You know, we haven't had it until recently. And even if you have it, you have to do what is being done in these experiments, which is to change the brightness and look into the change the iris and the exposure and look into the plasma, because if you just assume it's just a discharge, you're missing the beauty that's going on inside. And so they may have worked out how to, if I do X, Y, and Z, I can do this over there, and that thing over there falls apart. Yay! But in what you're seeing here, you're seeing something that's constructing. It's constructing. It's a beauty of nature what's going on, and right on that screen there, that image there. That's one of the most beautiful things I've seen in my life. You know, these interactions that we talked about here. You know, incredible levels of interaction that you're seeing here, just in a few frames. It's just so beautiful. So beautiful. You know, I think that those are some of the, as a previous, in my previous life as a owner of an animation company, you know, this is some of the most beautiful sequences of frames I've ever seen in my life. It's just, what do we got there? From this frame, that frame, 1, 2, 3, 4, 5, I think, and then the boom. I think that's some of the 6 most beautiful frames I've ever seen in my life. Yeah, let's all have a round of applause for Hank and David, for Alan Cuss, for Alan Goldwater, and for all of those Lena researchers that have died, including Martin Fleischmann. And yeah. Bestoic Primer, you made it here, but I'm just about to go. I'm sorry. Kim, I'll be on my way home. Thanks for all of your support. Really, I want to say thank you, Kim, for all of your support. It's been a difficult best part of 10 years, and a big hand for you. Okay, so thank you very much for your time, and look into what I've shared today, and please ask your questions. If you find anything interesting, let me know. This is a thing that we are doing together. So with that, I will say adieu, buenas noches, do svidania, dobro noc, buenas noches again. So anyway, see you later.